In this video, we'll be completing a one sample t interval for mu. You've already completed the steps of this in previous lessons, but now we're putting it all together into one problem. So we'll be looking at the t distribution using table B, and we'll be creating a confidence interval. In this particular problem, we have several groups studying auto exhaust admissions, and specifically, we're looking for nitrogen oxide levels. So we know that we have a mean nitrogen oxide reading of 1.2675 grams per mile with a standard deviation of 0.3332. First, we want to create a 95% confidence interval for the mean amount of nitrogen oxides emitted by light-duty engines of this type. So we're going to use our four-step process with our state, plan, do, and conclude. So first we have to state what we're doing, which is that we want to create the 95% confidence interval for the mean amount of nitrogen oxides emitted by these type of engines. For planning, we're going to check to make sure all of the conditions were met, and then we're going to do a one sample t interval. So first condition is that we need to do a random sample. And in the problem, it said specifically that we are going to take a random sample of 40 engines. Our second condition is to look for independence. We're not selecting with replacement, but we are assuming that 40 engines is less than 10% of the population because it makes sense that there would be more than 400 light-duty engines. Next, we want to make sure that we're using the central limit theorem since we don't know that the original distribution was normal, and we can use that because we have a sample size larger than 30. Next, we'll finally construct our interval. So we're using the given mean of 1.2675 and standard deviation of 0.3332, and we're going to use our degrees of freedom, which is 1 minus the sample size. So 40 minus 1 is 39. We're going to go over to our table, and there is no 39 on table B. So we have to round down, and the next smallest number would be 30. So we're going to use the row for 30, and the column, if you look across the bottom, we're doing a 95% confidence interval. And those two rows and columns meet at 2.042. So that is our critical t value. So we're going to use our formula for confidence intervals for mu, our x bar plus or minus critical t times the standard deviation divided by the square root of the sample size. Plug in all of our values, and then we'll finally simplify as far as we can until we're doing the addition and subtraction problem to get our interval. So our confidence interval ranges from 1.1599 to 1.3751. And then our last step is our conclusion. So we can say that we are 95% confident that the interval from 1.1599 to 1.3751 grams per mile captures the true mean level of nitrogen oxides emitted by this type of light-duty engine.